All right, today we are going to go over factoring. And there are two types of factors. So we're going to factor, meaning finding factors of integers, numbers, and those factors are going to be divisible into that number. So when we talk about factors of 12, we talk about numbers like 1, 2, 3, 4, not 5. 5 doesn't go into 12. 6 does, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, 11, and 12. So we know that those numbers are going to always be between 1 and the number itself. So we want to find those numbers between 1 and 12, including 1 and 12. 1 will always go into the number, and the original number will always go into the number itself. So we would always be between that. And as you see, we have what we call factor pairs. So 1 and 12 are pairs. 1 times 12, 2 times 6 equals 12, 3 times 4 equals 12. So listing them out and going between 1 and 12 is not always the most efficient way. 1 all the way to 20. What if we had 100? What are we going to do? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to test numbers 1 through 100. That's not very efficient. So what technique that I like to introduce are utilizing those factor pairs. So when I start with 1, I'm going to also write 20, which is its factor pair. And then I'm going to move sequentially down. So my next number is 2. 2 goes into 20, and then I'm going to write its factor pair. 3 does not go into 20. 4 does. 4 and 5 is its factor pair. And what would the next number come after 4? 5. Well, we don't have to do that because we already have done 5. And we don't have to do 6 through 20 because I've already tested. I've already checked for numbers between 5 and 20 because we didn't find it on the other side, its factor pair. So once I go around what I call the horn, I've already completed those numbers 5 through 20. So this is a real efficient way of making sure that we have gotten all of the factor pairs. Typically, when we have to find factors, listing the factors, oftentimes we'll skip numbers or forget numbers. So this technique is really nice. Now let's take a look at this. I want to ask you a question. How do I know that there's no number, that there's not a factor between 10 and 20? How do I know that by looking at this diagram? Well, the reason is its pair. If there was a factor between 10 and 20, its pair would be in between these two numbers on the other side. And we know that there's no whole number between 1 and 2, so I know that there will not be a factor pair between 10 and 20. That is a whole number. All right, so we know that factors always have to be whole numbers, or actually integers, or actually, natural numbers. 0 is not a factor. So, and the important thing is that this is really scratch work. So this isn't our answer. What we want to do is we want to then list those factors in numerical order, and we want to differentiate them with commas because they are unique. That is a list of each of the numbers that are divisible into 20. So it's important that we write them in numerical order, and it's important that we include commas. So let's look at the problem number 36. So 1 and 36, 2 goes into it, 18, 3 goes into it, 12, 4 goes into it, 9, 5 doesn't, 6, and 6's factor pair is 6 itself. So I've gone around the horn. I don't have to do 7, 8, or any of those numbers up to 36 because I've already done that left side. So when I list them, 1, 2, 3, 4, 6, 9, 12, 18, 36, you notice that I didn't write 6 twice because I want each unique and individual number that goes into it. There would be no reason for me to list 6 twice. That would be redundant. So let's take a moment, pause the video, and I'd like you to write all the factors of each of those 5 problems. So this is you try, take a moment, pause the video, list your factors of 13, 22, 24, 18, and 29, and then unpause it when you're ready. Good. So 13 factor pairs are 1 and 13. 13 is a prime number. So a prime number has exactly 2 factors, 1 and the number itself. So we know that our factor pairs, we're only going to have 2 factor pairs. 22 would be 1 and 22, 2 and 11, 3, no, 4, no, 5, no, 6, 7, 8, 9, 10, no, and now we hit 11. So I know my factors are going to be 1, 2, 11, and 22. 24, I'm going to do 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 doesn't go into it. So I have my list of factors, and I'm going to write them in numerical order using commas to separate my answers. 18, so 1 and 18, 2 and 9, 3 and 6, 4 doesn't go into 18, 5 doesn't go into 18, and then you notice that I'm around the horn. So 1, 2, 3, 6, 9, 18 are my factor pairs. 29 is prime, so I know that the factor pairs are going to be 1 and 29. So hopefully that helps you. That's a nice systematic way of approaching factors of numbers so you're not missing any, and more efficient that you're only trying the least amount of numbers in order to find your complete list. You will also see situations where they will ask you for the prime factorization of a number. So prime factorization is going to give us all of the prime factors, the product of prime factors that equal your number. So the first step is to break this into factor pairs. So pick a factor pair when multiplied equal 12. So well, let's try 2 and 6. 2 times 6 equals 12. And so the numbers that I pick are always going to be a product of that original number. And then we're going to break it down until it becomes a prime number. Well, 2 is a prime number, so I can't break that down. 6 can be broken down to 2 and 3. 2 is prime, so I can't break that down, and 3 is prime. Notice I don't break it into 1 and 3 because 1 is not a prime number. It is neither prime nor composite. 6 was composite, so I can break it down. I can continue to break it down until I get prime factors. So that is what prime factorization. And notice when I write my answer, I take all of the prime numbers and I write it as a product. 2 times 2 times 3 is the prime factorization of 12. If we multiplied 2 times 2 times 3, we would get 12. Now, here's an interesting thing. What if I didn't pick 2 and 6? What if I picked 3 and 4 as my prime factors? It's because somebody may choose 2 and 6, somebody might choose 3 and 4. Both are correct factors of 12, factor pairs of 12. And so let's do this. So 3 is prime, so I can't break that down. 4 is composite, so I can break that down into 2 times 2. And then remember, I'm going to write those prime numbers in numeric order, and we notice that we end up with the same prime factorization. So it doesn't matter which ones we start with, we're always going to end up with the same prime factors of the number. Let's do 20. I'm going to break 20 into 2 and 10. 2 is prime, 10 is composite, so I'll break 10 into 2 times 5. So 5 is prime, and so my prime factorization ends up being 2 times 2 times 5. Let's do 36. I'm going to choose 2 numbers that are not prime, 6 and 6. Those are both composite, so I still need to break both of those. I'm not going to circle those. I would never circle a composite number because I can break that down into prime factors. So 6 actually gets broken into 2 and 3. So I'm going to write it in numerical order. I have 2 times 2 times 3 times 3. Some questions, some books would, when we have identical numbers, you would write it in exponential form. You may see answers like that, 2 squared times 5. What in our work, we're going to leave it in this standard. We're not going to write exponential form because we're going to utilize this later with factoring polynomials and this, or reducing fractions with quadratic answers, and this will be more beneficial to us. So here are 4 problems for you to try. Take a moment, pause the video, do the prime factorization of 16, 34, 69, and 65, and when you're ready, push play and we'll go over the answers. So 16, I'm going to break that into 4 and 4. I did. You may not end up doing that. You may have done 2 and 8, but I did 4 and 4, and then I broke 4 down to 2 times 2, and I broke that 4 down to 2 times 2. So the prime factorization of 16 would be 2 times 2 times 2 times 2. 34. 34 is a composite number, so I can break that into 2 and 17. 2 is prime, and 17 is prime. So I got 2 times 17. 69, also a composite number. A lot of people think 69 is a prime number. That's not true. 3 goes into 69 23 times. 3 is prime, and 23 is prime. So the prime factorization would be 3 times 23. 65, I know that 5 times 13 equals 65, so 5 is a prime number at 13. So my prime factorization of 65 would be 5 times 13. What if I had a number like 19? What is the prime factorization of 19? The prime factorization of 19 would be 19. So any prime number is going to be its prime factorization. Some students make the mistake and write 1 times 19. That is wrong because 1 is not prime. Okay, it is neither prime nor composite. So we would understand that any prime number would be its own prime factorization. Hope that helps. Let me know if you have any questions.